I'm going to briefly demonstrate how to use a digital experiment, that is, online simulation that allows you to take data, in this case, to measure Antoine constants for a single component. The idea is we inject the liquid into an evacuated tank where we set the temperature with a slider and we allow it to come to equilibrium, and we want to measure the pressure when we have vapor liquid equilibrium, which means we need to inject enough liquid that it all vaporizes, still some liquid left, and we can change the volume that we inject. We also can pick which species we inject. So the unknown, there are 5 unknown species. You can see in the simulation here, we can pick A through E. And then the simulation has buttons. The directions tell more detail about the experiment. And then the worksheet tells procedure, allows you to collect data and then calculate Antoine's constants, and it explains how to do that. So let's look at this simulation. Let's look at this digital experiment. So here's the simulation where we can set the temperature. We can select the volume to inject. We can then fill the syringe and we inject the syringe. And now it's going to take some time for the system to reach equilibrium. We inject the liquid, it has to, some of it or all of it has to vaporize. So the system's reaching equilibrium. If we mouse over the pressure gauge, then we can see the pressure is increasing as the liquid's vaporizing and the system's equilibrating. And so we just have to wait in order to measure the saturation pressure, assuming we've injected enough liquid. Now, we can read off the pressure in bar. In this case, it looks like about 3.1 bar. We can repeat this at various temperatures and then determine the Antoine's constant by fitting the data at enough temperatures to the Antoine equation. And so the idea is to simulate a physical experiment that we could do that would effectively measure Antoine's constants.